All right. Um, so I'm Brad Hanson. I'm a cooperative extension weed science specialist, and I was asked to provide a 5-minute update on our research on branched broomrape. So I've got a few slides, and I'll try to burn through those in the next couple of minutes. Uh, the work we're doing here is part of a multi-pronged approach. Several of us at UC Davis, including Mohsen Mesgaran, um, graduate student Matt Fatino, postdoc Wally Asipitan, as well as a number of non-UC Davis cooperators are involved in this work. And it's funded by several entities besides CTRI. Other researchers, including cooperative extension folks like Jean Miao and Amber Benkesi and others, Davis faculty and specialists, Israeli researchers, and more recently some UC Davis Chile Life Science Innovation Center scientists. This has been funded initially by the CTRI with later funding from the USDA IR4 program, the California Department of Pesticide Regulation, and a relatively large project was funded by CDFA, Specialty Crop Block Grant funding 2 years ago. Just a quick overview of the work we're doing on branched broomrape in California processing tomatoes. The herbicide approaches that my program is leading on are based on the Israeli developed Picket system. It's a decision support system based on the Israelis' work over the last 20 years on Egyptian broomrape that we're trying to adapt to branched broomrape in California. The big barriers here are that the herbicides that the Israelis use are not currently registered for this use in California. So we're developing the efficacy work as well as the crop safety work to facilitate registration. In addition to that, or as a part of that, we're also working on some modeling of this particular species and our system. This is basically to confirm and fine tune the thermal decision support model so that we can time our applications based on this species in this state. Outside of the herbicide work, we're also doing some work related to fumigants, biosolarization, and other eradication programs. Mohsen and cooperators are working on some remote sensing and detection and identification projects. I'm not going to present any of those data today. And then as part of the CDFA project, Wally and our team is working on some equipment sanitation procedures. Basically the idea of how can we kill broomrape seed or disinfest equipment before it moves into a field or out of the field. Because I've only got a couple of minutes here, I want to spend time today talking about the Picket program. This is our herbicide chemigation program that's based on the Israelis' Picket program. That's an acronym that makes more sense in Hebrew than it does in English, so I won't belabor that. But over the last couple of years, we've done quite a bit of work trying to register the two primary products that the Israelis have developed for this use. Sulfosulfuron, which is in California is a wheat herbicide called Outrider, and an imidazoline herbicide called Imazapic, which is called Cadre in the US or Plateau in the non-crop market. During 2019, we conducted 2 trials at UC Davis in a non-infested site to look at crop safety of these chemigation approaches. We also initiated a plant back trial in 2019. So it was tomatoes in 2019 and then planted back to, I think, 6 rotational crops in 2020. In 2020, this was a little bit COVID impacted, but we did get one crop safety trial out, again, a non-infested site on the Davis campus. We did the rotational crop portion of that study I mentioned that was initiated in 2019. In 2020, we had our first efficacy trial in an infested site in Yolo County. We also, with the IR4 program, also began the residue portion of the projects to determine sulfosulfuron residues in the tomato crop. We did 2 of those at the Davis location, and there were several others conducted in other locations around the country, as is normal during the IR4 process. Just a quick rundown of results and some challenges based on the 2019 and 2020 projects. First, good news, the crop safety looked fairly good with the PPI applications of sulfosulfuron and with the 5 times per season chemigation applications of Imazapic. Those were applied at various growing degree day timings through the drip system right into the root zone of the tomatoes. So that was very positive. I think we went up to what we were calling our nominal 2x rate of both of these herbicides, and we saw no problems with the crop safety on the tomato. Plant back study, there will be some rotational crop limitations, particularly with the sulfosulfuron. I don't have any results that I'll present here, but we had some issues with carryover to corn. We followed tomatoes a year later with wheat, corn, dry bean, safflower, melon, and the field corn had some problems with sulfosulfuron. So there would, if that were to be registered, there will be some adjustments will have to be made to crop rotations. Efficacy, this was a little bit disappointing. I would say our picket treatments were suppressive to broomrape, but not an amazing level of control. I think we need to do some timing, some adjustments to both the rate and the timing to find a way to make this more effective in our soils and our system, and with branch broomrape instead of Egyptian broomrape, which is what this was based on. Probably worse news here, registration outlook. Sulfosulfuron looks very feasible. It's already registered in California as a wheat herbicide, so adding tomato to the label is doable. Imazapic does not seem to have a path forward. We had quite a few discussions with the registrant, BASF, and there's just too many environmental fate studies that would have to be done in California for this to be feasible in the short term and probably at all. So that was a real monkey wrench that got put into the program kind of late in the 2020 growing season. Just a quick overview of what that field site looked like in north of Woodland. So my student Matt Fatino led on this, and we did basically 3 times a weekly broomrape scouting most of the season long. Broomrape is not a very large stature plant, and what he did, you can see on the right-hand photo, use different color flags every week. So we got both a spatial and temporal analysis of when broomrape was coming up in our various treatments. Beneficial to a research standpoint, detrimental if you're the grower. There was a lot of broomrape in this field. The shot you're seeing here is probably about 2 acres. I think we used around 5,000 wire flags out there marking broomrape in the trial area and in a adjacent area that we plan to use in 2021. So there was a lot of broomrape out there. You can't really see the plots in this photo, but the plots are 100 feet long, and the back half of the experiment, the back half where the tomatoes are dying, that was sprayed with Roundup late in the season, and that's outside of the chemigation area. But basically what you're looking at in the foreground is 4 replicates of 100-foot long chemigation plots with broomrape coming up all throughout that field. As I mentioned, these data are total broomrape clusters over the course of the season, and I won't belabor treatments here, but 1 and 2 were non-treated. Treatment 12 was a matrix-only program. So, and the rest of the treatments 3 through 11 were various picket, imazapic, sulfosulfuron treatments. As I mentioned a moment ago, suppressive but not amazing levels of control. So I think we have some work to do with our rates and our timing to dial this in. Just to show those data a slightly different way, the data I showed you on the bar chart were these end of season evaluations, but I would just show that we did see suppression over time. See, these are weekly summations of broomrape flagging, and essentially we had our non-treated or non-picket treatments were all these 3 high lines. A lot of our programs were in the middle range here, various imazamox, imazapic, and a few other herbicides, and a few that were better than others. So I think we have some opportunity, but we have some work to do to make this reasonably effective. So why didn't this work? First one is probably that we're looking at a different species than what the decision support system was built on. We have branch broomrape versus the Egyptian broomrape that the Israelis spent 20 years working on. Our soils are different. Probably that's a contributing factor, which makes me think that with a rate adjustment, we can probably make this work in some better fashion. The growing degree day model may need some adjustment, primarily because of the difference in species, branch versus Egyptian. We may have started a little bit late because of the timing of the phenology of the branch broomrape versus Egyptian. I mentioned the problems with imazapic, so we're going to refocus on imazamox instead, and I'll just a quick rundown of our our 2021 plan. So the idea is we'll pivot to imazamox. Imazamox, or Raptor, is registered in California, not for tomato, but it is already registered in the state and has a much more favorable pathway to registration. Imazamox is not typically used as a soil herbicide, so it's expected to be somewhat less effective than imazapic at comparable rates. But I think that will actually be a benefit from our plant back issues. And I'm hopeful that with repeated chemigation, that impact of that shorter half-life or lesser soil activity can be minimized. The work that we plan in California will be largely done with funding from the IR4 program and that specialty crop block grant. What I've proposed for the CTRI's consideration is basically another location to be conducted very soon by cooperators in Chile. The UC Davis Chile Life Sciences Innovation Center researchers have been working on branch broomrape in their tomato processing system. And being a Southern Hemisphere location, they can start that ASAP. They'd like to start that within the next month or so. The idea is they'll look at our imazamox protocol that I put together with our collaborators and cooperators, put that out in Chile soon, so that by the time we come into the California growing season, we'll know how their results have panned out, and then we can make some adjustments to ours if necessary for the California project. So basically we get 2 iterations of this experiment during the same calendar year. And the Chileans have a much more widespread problem with branch broomrape. So, bad for them, but it's better from a research standpoint. The California issue is so scattered right now that we don't have a lot of locations to do efficacy work. So I will stop with that and just remind you what broomrape looks like. And I think you're all well aware of the risk this poses to the industry. And I'll stop with my contact information, and I will stop sharing.